Alright, let's take a look at this guy here. We got f of x is equal to negative x squared plus 3x. So hopefully you know how to take derivatives. I will have a link taking you straight to how to take derivatives. I worked quite a few examples, but anyway, so the first thing I said, it doesn't matter how we get to the end here, but I guess I better write our interval. We're on a closed interval between 0 and 3. I've been saying take the derivative first, but it doesn't matter. You can plug your endpoints in first, get those numbers. You know, what difference does it make? But we'll just take the derivative first. So we got f prime of x is equal to negative 2x plus 3, and then we want to get those critical numbers, and so we set the derivative equal to 0. Right? This is where the slope, if we were looking at a graph where the tangent line is 0, get the solution to this equation, find the solutions. We're going to plug, let's see, take negative 3 over, divide by negative 2, right? Hopefully you can solve for x in this problem at this point in your career. So x is equal to 3 halves. So we got one critical number. Now what we want to do is take this 3 halves, that negative over negative is going to cancel out. And want to go ahead and take the 3 halves and plug it in to our function up here. So we got 3 halves squared plus 3 times 3 halves. So we're dealing with some fractions here. Hopefully that doesn't scare you off. I'm just going to go ahead and skip all the fraction nonsense, and I came up with 9/4. Alright, so f of 3 halves is equal to 9/4. Hopefully you know how to get there. I'm not going to get into all that. Now what we wanted to do is plug in our endpoints. So we want to plug in 0, and that was negative 0 squared plus 3 times 0. Since we can't see the function on the screen, I'll just go ahead and plug it in. Alright, plugging in f of 0, we get 0. And then remember our other endpoint was 3. So we want to plug that in. And it looks like we get 0 also, right? That's going to be a negative 9 plus 9 is 0. So we got, and then I'm going to go ahead, well, no, I guess I don't have to. It's already written up here. So our minimum, as you can see, we have 2 of them. Yes, we do. They're the same, 0, 0. And then this is going to be our max up here. Right? So I guess I'll just write it out here. Our absolute maximum, now I'm writing these as points here now, is going to be 3 halves. Remember these numbers. I'm going to bring the graph up here in a minute so we can kind of look at this. And then the absolute minimum. And yes, there happens to be 2 of them. So we got 0, 0, and 3, 0. All right. Okay. Well, let's look at the graph. Okay. So here's the graph we're interested in, and we were between 0. So here's x on the x-axis, 0 and 3. Right, between 0 and 3. So you can see where the maximum is occurring. That was at 3 halves, which you can see 1.5 here, and then at 9/4, which is 2.25, and then between 0, right, is the same y value, and then right here, and so as you can see, both of our, we got 2 minimums, absolute minimums that is, and a maximum, absolute max. Alright, so it really helps out to to graph this stuff and look at a graph. So the procedures here are pretty easy. Let's work some more.